Oh, yeah. We welcome you back to our continuing, never ending note series on 1 11. 1 11 is one of the big backbones of this entire unit, Unit 1. It is also a very important unit as it introduces chemistry vocabulary that we simply use the entire year. When last we left off, we were talking about molecules. Molecules are any example of a joined substance that they kind of are able to go around together. They're a little unit. They're hanging out together. Atoms that have chemically joined and they're hanging out together. Molecules often involve atoms that are sharing electrons. That is chemically joined, sharing electrons amongst the other atoms that they are bonded to on the molecule. If it happens to be the same atoms joined, the same type of atom joined together, meaning two atoms that have the same number of protons, it would be a diatomic element. If they are atoms from different elements joined up, that molecule would be classified as a compound. Compound is two or more different elements chemically combined. Molecules can form compounds. Molecules can also be elements. When last we looked in our last set of notes on this, last video on this, we had two of the same atoms joining up here, two of the same atoms joining up in here. These happen to, in this case, represent hydrogen atoms joined together. H2 is diatomic. These are O's joined together. O2 is diatomic. It's part of the Brinkelhoff. The hydrogens are the H-Hoff. Oxygens are the O-Hoff. Brinkelhoff. They are found in twos. These two atoms are joined together and they can go anywhere in this container together. They're able to free to move around. These two atoms are free to move around in the container. These two oxygen atoms are free to move around in the container. Since these two atoms are the same, that's the oxygen element. These two hydrogen atoms are the same. They would be hydrogen element, and these would be another classified as the hydrogen element since they are the same type of atoms joined. However, in this container, we have two different elements floating around in here. So this container would not be pure because it has both oxygens and hydrogens in here. If these oxygens were not in here, or if these hydrogens were not in here, if these hydrogens were not in this container, now this container would have pure oxygen in it. But as soon as these hydrogens are in the container, it's no longer pure. It is a mixture. It is a mixture. If these oxygens were not in the container, now this container would be pure hydrogen. But as soon as the oxygen's in here, it is not pure anymore. We have hydrogens and oxygens. That's two different things. Pure means two different things, and they're not joined chemically. If the two different things are joined chemically, it would be pure. Let me show you. In a chemical reaction, the atoms are first broken apart from what they are originally joined to. So the chemical reactions start when energy is used to smash apart those molecules. They could join up together with who they were with, but for a chemical reaction to occur, they must join with something different. So this time the oxygens are no longer joining with other oxygens, they're now joining with hydrogens. So now the hydrogens have joined with the oxygens. These hydrogens have joined with that oxygen. We now have two different atoms or atoms from two different elements joining. We now have a molecule that would be classified as a compound. Wherever this oxygen goes, those hydrogens would follow. Wherever this oxygen would go, these hydrogens would follow. So it is a molecule. They're free to move wherever they want. It is a molecule. But they have different atoms on the molecule. So it would be called a molecular compound. And now, believe it or not, as soon as those hydrogens broke apart and the oxygens broke apart and they joined up with the hydrogens, the oxygens joined up with the hydrogens, we now have something that would be classified as pure. Pure means one thing is in there, one type of thing. Well, I have one type of thing in here now. I have a water molecules. I have water molecules in here. This is a water molecule. It is a compound, two hydrogens on an oxygen. This is the same thing. This is also a water molecule. I have the same type of thing in there. Pure means same type of thing. Pure can be a compound if there's only one type of compound in there. So pure means one kind of thing in there, only one type of thing is present. Pure can be a compound, such as water, if the only thing in there is water. If we put something else in there with the water, it would no longer be pure. So compounds can be pure, but compounds can be molecules. They don't have to be. A compound is a molecule if that compound has two or more different atoms joined together and they're going around in groups. So when we look right here, this is going around as a group. This is going around as a group. If they're free to move around as a group, it is a molecule. Not all compounds are free to move around as a group. For instance, compounds can form salt. A salt is a type of compound. Salt is not free to move around on its own. They're kind of locked in place when it is a salt. To represent an element, you need one symbol. That symbol can have more than one letter. To represent a compound, you need more than one symbol. So to represent this compound right here, I would need H for hydrogen, and I have two of them, so it would be H2, and that molecule has one O, it would be H2O. That is the formula for the water molecule, which is a compound. Compounds can be broken down further into simpler substances. We saw here that elements could not be. Element cannot be broken down further into simpler substances. Compounds can be broken down further into simpler substances. So right here I have a compound. How could I break this down into different substances? Well, if I run an electric current through this water, that electric current can provide the energy to break these hydrogens off. It can provide the energy to break the hydrogens off this molecule. It was a compound. But if this oxygen turns around and joins with this oxygen instead of the hydrogens, these hydrogens join up, these hydrogens join up, I've broken the compound water, H2O, up into simpler substances, oxygens and hydrogens. I cannot break these hydrogens up into something other than hydrogen. If I break these hydrogens up, I can break them up into hydrogen atoms, but they join back up together. An element just means one type of atom. Elements mean they're pure and you not break them down into anything else. You can't break them up into anything else. Hydrogen, the only thing there that is hydrogen. And that gets us to a very important question. So this understanding now of what happens, what's the difference between elements and compounds and so forth, this gets us back to that little demonstration we saw. Right here is the atoms on a copper penny. So the atom was the copper penny was mostly copper, and that the pennies that they used, the mint was like the pre-1962, which still had a high percentage of copper, but it still was an alloy. But for the purposes of this, the penny was mostly copper. And they dropped it into this solution. They dropped the copper penny. So this is the copper penny right here. It was dropped into solution, and that solution had zinc ions floating around in it. Now, what happened when that penny turned silver is a chemical reaction occurred where these zinc atoms right here replaced the copper atoms on the surface of the penny. So the copper atoms went into solution, and the zinc atoms replaced them on the surface of the penny. So when you pull the penny out then, and if you looked at the penny right here, from the outside of the penny, it's going to look silver. This is the outside, this is the inside. And it's because copper atoms were replaced by the zinc atoms, and now it looks silver. That was a chemical reaction that occurred. Copper left the solution and formed ions. The zinc replaced it on the surface of that penny. But how did they make the penny look gold? Well, they pulled the copper penny out of the solution after it was coated in a. Here's our copper atoms on the inside. These are our zinc atoms now on the outside. This is now going to look silver to our eyes because the penny's coated with zinc. Then they put it in the burner flame. They put that penny in the burner flame secondly, and what happened is the zinc melted and the copper melted. As these atoms melt, they begin to move a little bit. So some of the copper atoms were able to float or move to the surface. Some of the copper atoms now are moving to the surface, and the zinc atoms are going to the inside. So now some of the copper's on the outside, some of the zinc's moving to the inside. Now we have a mixture. The atoms are still there. And there are different kinds of atoms in this penny now. There's the copper atoms and the zinc atoms, but they are mixed all over the place. And to our eye, having some zinc atoms right next to the copper atoms gave an entirely different appearance. Having the zinc atoms right next to the copper atoms to our eyes looked gold. It looks like gold to our eyes. It's not gold because these atoms were not gold. These atoms were copper or zinc. You cannot change one atom into another by chemical reactions or by making mixtures. That's not how it happens. The only way we could turn a copper atom into a gold atom or a zinc atom into gold atom is by changing numbers of protons. So this is an alloy. These yellow atoms are actually not yellow at all. They are really just copper or zinc next to each other. It just looked yellow to our eyes, and that's an alloy called brass. So why isn't this a compound then? Well, because there's copper atoms and zinc atoms, and they are not chemically joined here. They just melted and mixed together. If we heat this up again, or if we use other physical properties, we can melt this and separate these things very easily. We can use physical properties to separate the zinc atoms out of there. So here goes the zinc atoms. We can get those zinc atoms back out of there, leaving behind the copper atoms. The copper atoms are the orange or the orangish colored, reddish orange colored ones right here. Those are the copper atoms. They're not joined chemically. The copper atoms were not joined chemically with the zinc atoms. If they were, it would have been a compound. So one thing that's unique about compounds is that they are atoms that have joined, and when they join to form the compound, they lose their properties. So when we make water, I have oxygen atoms. Oxygen has atoms, or the oxygen element has its own properties. I have hydrogen molecules which make up hydrogen. They have their own properties. A property of hydrogen is that it burns. Hydrogen atoms are flammable. That is a chemical property of them. Oxygen atoms or oxygen molecules. Hydrogen molecules burn easy. Oxygen helps things to burn. So if I bring a burner flame in here, what will happen is it will be enough energy to separate these oxygen atoms or these hydrogen atoms, and they will join with the oxygen atoms to form water. Hydrogen burns, oxygen helps things burn, but now we've made the compound known as water. What does water do? What does water do? Water puts out things that are burning. Water would put out the things that are burning, such as that burner. Elements such as hydrogen and oxygen have their own properties. When those elements join together to form a compound, those elements lose their properties. Hydrogen, highly flammable. Oxygen helps things to be flammable. Oxygen helps things burn. When the hydrogens join with the oxygen, they put things out burning. Things out that are burning. Compounds have their own unique set of properties, and as we mentioned, compounds can be separated into the elements that make them up. Thank you, and we will move on to our final video, if you believe it's possibly true, our final video on 1-11.